Hello, welcome to this video on factorizing quadratics. This relies on you being able to expand two brackets. If you can expand two brackets, you can factorize. Okay, so let's see how this goes. The start is here, so pause the video and use the grid method to expand these two sets of brackets. Then come back when you're ready for the answer. Okay, welcome back. So this should be quick now, a quick recap. So if I expand the first one, which is question A, then here's my grid. So x plus 5 times x plus 4. Fill the grid in. X times x is x squared. X times positive 5 is positive 5x. X times positive 4 is positive 4x. And 5 times 4 is positive 20. And remember, these diagonal terms will always be like terms. They will combine. So you're going to get x squared plus 9x plus 20. First one's done. And part B in it is very similar. Just watch the negative numbers. Okay, so this time it's x take 5, x take 4. Well, that's going to be x squared. This will be negative 5x. This is negative 4x. And be careful, in this bottom right part of the grid, negative 5 times negative 4 is positive 20. And then we're done. You're going to get x squared, and this time negative 4x take away 5x is negative 9x plus 20. And you might have started seeing patterns here. We're going to need them for this lesson, because today we're going to factorize a quadratic expression. So pause the video here and put the nod down. And you should know from previous years that factorizing is the inverse of expanding. Okay, so if you're factorizing an expression, okay, you're putting it back into brackets. And this is an unbelievably important skill. So factorizing is the opposite of expanding. It means put something back into brackets. Okay, so here's the first example. Pause the video. Have a go at putting this back into two brackets. Maybe reverse the grid, then come back when you're ready. Okay, welcome back. So you should know that this is bound to look like this. Two brackets. So I'm going to try and write the grid down for this question and then reverse it. Because we know, don't we, that this x squared here is always going to go here. And this positive 12, remember the pure number is always in the bottom right corner of the box. I know I need x and x here, all right, to make the x squared. And then hopefully you started seeing patterns and realize that the number here and the number here have to multiply to make 12. But at the same time, that was a bad choice of color, sorry. These yellow numbers here have to times to make 12. And remember, they must give you two numbers here that add to make 7. Remember, because these green terms, these diagonal terms, always combine to make the middle term. So you could try, 12 is 6 times 2, but that wouldn't work. What works here, I think, is x plus 3 and x plus 4, because x times 3 is positive 3x, and x times 4 is positive 4x. And can you see that 4x add 3x is 7x? So we're good to go. We factorized it. X plus 3 times x plus 4. We've done it. Okay. Example 2 is here. Pause the video, have a go, and come back when you're ready. Okay, welcome back. So this one here, again, I'm going to reverse the grid. I won't put that there in a minute. Let's reverse the grid down. I know that it definitely came from two brackets again, and there was definitely an x here and an x here. All right, so x squared would go here, and 24 goes here. Obviously, x and x, and these yellow numbers, they have to multiply to make 24, and these green numbers have to combine to make 10. So I did try 8 times 3, but that wouldn't work. I think what I'm looking for here is x plus 4 and x plus 6. 6 times 4 is 24. And then this would be positive 6x. That's positive 4x. and 6x add 4x is definitely 10x. So I've done it. X plus 4 times x plus 6. And the last example is here. So pause the video, have a go, come back when you're ready. Okay, welcome back. Then this one slightly more complicated, but not too bad. Again, it must have come from two brackets. It's a pure quadratic. So x squared here and 24 here. So x and x. So this time they have to multiply the 24. But see, this time they have to combine to make negative 11. Well, I'm looking at 24. I know one factored pair of 24 is 8 times 3. And I can see 3 and 8. I can see 11 here. 3 and 8 is 11. So definitely, I think it's going to be 3 and 8 here. But how would you make negative 11? Well, I think you would need negative 8x here and negative 3x here, because negative 8 take away 3 is negative 11. So I think you need two minus signs here. And this is right, because negative 3 times negative 8 is positive 24. A negative times a negative makes a positive. So I'm done with this one as well. It's going to be x take 3 times x take away 8. And you'll soon start spotting patterns on the main task, which is here. Okay, so pause the video, have a go at these, and then come back when you're ready for the answers. There is also a challenge question after this, but main task answers first, okay? In 5, 4, 3, 2, 1. Here they are. You'll notice on question 11, you may have had a take 1 times a take 1, but this is the same as a take 1 squared, because a take 1 times by itself, that's what squaring means. Okay, the challenge question is coming up actually as well in 5, 4, 3, 2, 1. Here it is, and the answer is going to follow in 5, 4, 3, 2, 1. Yeah. And then next comes the checking question. So pause the video, have a go at both of these, and come back when you're ready for the answers. Okay, welcome back. So these are more tricky. They hint at the next step. So question 1, I got x squared plus 6x minus 27. Okay. And I know it must look like, two brackets again, so I'll put it by here this time. A bit less space than before. So let's try it then. Right. I know, don't I, right? X squared, and this time at the bottom is negative 27. Right. So definitely x and definitely x. These yellow numbers have to multiply to negative 27, but give me green numbers that make 6. And you should realize that if you want to make a negative number by multiplying, you need one positive number and one negative number. Because if you have two positive numbers, you get a positive answer here. And if you add two negative numbers, you get a negative answer here. So I know that the signs are going to be different to make a negative number, but they still multiply to make 27. Well, I think 9 times 3 is 27. And I did try 2 ways, but I think this way works. Because this would give you positive 9x, and this would give you minus 3x. And certainly negative 3 plus 9 is positive 6. So I'm good to go. All right, you will notice that when the end number is called a constant term, when this is negative, and it is here, the signs in the bracket are different. That's such an important shortcut, okay? So that's that one done. And then question 2 is even more strange, isn't it? Because it looks like something's missing. Like x squared minus 81. Normally it's x squared, then some x's, then a number. So this one's strange, but what I'm going to do here is going to make it even stranger. But bear with me. I think that x squared minus 81, you could write it like this, couldn't you? X squared plus 0 x's. There's no x's in this one in the middle, but it might help you see what's going on. Minus 81. And now, I think this actually comes out quite nice. So let me put my brackets here as well. It's a bit, that's a bit squashed. Let me fix that. That is shocking. Sorry, that was bad planning. Definitely 2 brackets, and definitely x, and definitely x. So let's get the box on a go. Right, so again, x squared here and negative 81 here. So patently I've got x and x here. And this time weird, right? Because these yellow numbers, they multiply to negative 81, but at the same time, give me 2 numbers that make this 0 here. And the only way this can happen, all right, again, the signs are different because it's a negative number here. So definitely positive and negative. And check this, this will work. X plus 9, x take 9, because this gives you minus 9x, and this gives you positive 9x. And negative 9 plus 9 is 0. That's the worst 0 ever, sorry. So this works. Tick. So we're done. X plus 9, x minus 9. And the more work you start doing on factorizing, you'll soon start to spot a really cool pattern with expressions that look like this. Okay, so look out for that in the future. But for now, we're all done. Nice one.